Okay. Sure. Okay, guys. So let's start. So yesterday we have discussed about DPD, right? DPD here, which is about dead peer detection. So what is the meaning of dead peer detection here? I'll just brief it out again. So DPD means instead of using keep alive messages, the periodic keep alive. Okay, because okay, so instead of using periodic keep alive messages, we are going to use on demand messages. On demand keep alive. Okay, which is known as DPD. Okay, so this is on demand concept we have. So for example, let's consider these are the two sites, site A and site B, and we have configured a VPN between them. And after that, in the case number one, if you have, let's consider the scenario number one, the case one here. If you have enabled a keep alive here, so now both the sites would exchange the keep alive messages after the particular time period. So let's consider we have mentioned here 10 seconds, for example, or 5 seconds, whatever the timer is. So let's consider we have set the timer here the 5 seconds. I have set the timer here 5 seconds. So after every 5 seconds, both the sides, they would exchange the keep alive messages. Okay, they would exchange what? They would exchange the keep alive messages, and all these messages are what? By default, all these messages are encrypted here. Encrypted from here and encrypted on this. So on the both the sides, then what we have to perform on the both the sides, we have to perform encryption and decryption. So encryption here and then decryption, and along with that, encryption and decryption. So this is the unnecessary concepts we are adding. So this is okay for one scenario, this is good, but for the one scenario where continuously we are exchanging the data, so there we don't need any kind of keep alive messages, because if we are able to exchange the data, so it means tunnels are already up. So that is the one of the, you can say, one of the proof where we can say yes, the tunnels are up because we are able to exchange the data here. Okay, so in that scenario, that is not required because unnecessary encryption and decryption would happen. Because if I'll talk about in the context of the EIGRP and OSPF, so we don't have any kind of encryption there for the hello messages. Okay, but here we have encryption and decryption, and along with that we have hashing also on both the sides. So that's the reason the CPU utilization would be high on both the ends. So instead of using that, so what I'm going to use DPD here, because the concept is, Amit, in case if we are not using keep alive messages here, so how the site A would get to know that site B is like up after the like 30 minutes of idle timer here. So let's consider right now the session is idle here and for last 40 minutes here. So after that, if you want to exchange the data, and in case if you have not enabled any keep alive here, and after that, just like blindly, the site A is sending the data of 1 TB and the site B is already down. So obviously this data would be dropped there. Okay, so this is the unnecessary using of bandwidth, okay, and sending the data. So here we have a solution. Okay, let's consider the consider is key, for example, let's consider we have site A here and site B. We have site A and then we have site B. Okay, site A and site B. We have configured IPsec and everything. After that, we have to configure here and we have to configure no. So we have configured a VPN, like the timers and all. This is the, let's consider, this is the keep alive timers here. This is the command to enable the DPD here. So what concept will be there? Okay, like we would configure it. Let's consider right now. This is my session, which is up right now. And now this is consider, this is up here. And consider this is up on this side as well. Now we are not exchanging the, first we were exchanging the data. And after that now the session is idle here. Session is idle and we are not exchanging any data. So let's consider. So now no data exchange here. Okay. The session is idle. Okay. So we are not exchanging data. Everything is fine. So after that, now the site A want to exchange some data. Okay. So what would happen here? So this want to exchange the some data. So in this scenario, what happened here? Before sending the data, let's consider the session is idle. So before sending the data here, okay, this side just want to be sure, okay, just want to know that B site is up or not, because this is my idle time of time here of, let's consider 40 minutes, and we have not exchanged any data in between that. So the question is now, what about the another side? Is this up or not? I do not have any idea about it. Okay. So what is the concept here now? Before sending the data, it would keep it on hold, the data. So data would be on hold now. You can say this is data actually. And so it would be kind of on hold, and it would say, okay, first let me check it out. The side base is, let me check out that side B is up or not here. Okay, with DPD. So instead of sending the data, so first of all, it would send what packet here? It would send here one message or packet, you can say, which is DPD, dead peer detection. So this is kind of keep alive only, and as a are you there request. This is the name of your message. This is the name of your message. Are you there or not here? After that, let's consider this is the first message which is sending. This is now sent by the first message. Sent by what? Sent by side A to just get to know the side B is like up or down. So the first message and message name is are you there request here. So in case if this device is already up, so here we have two scenarios. The device could be up or device could be down. Just consider if device is up here. If device is up, this device would send as a reply, okay, this is, are you there? This is about, are you there? Okay, and after this side would get to know, okay, yes, that is alive, and after that, this is what? This is the data. Now, this is the case number one, where the device is up. So here in this scenario, you can say that side is up here. Okay, and continuously they are sending the data. Right. So guys, is this clear? So this is DPD concept here, dead peer detection. Any doubt, any questions in this? Yes, guys. Any doubt, any questions, anyone? Clear? Pawan saying
if the
clear, whatever
tunnel
other
is down,
students?
hello?
Yeah, please.
Yeah, if the tunnel is down, so with this message that will get activate?
No. If
Okay.
tunnel is down, that second scenario I'll explain now. Because here I have mentioned tunnel is, the site is up. Okay, now this is clear.
Yeah.
Second scenario is, what if site is down? So second scenario here. So let's consider this is the message here. That is the same, that keep alive message, which we call it as a DPD, and it's asking, are you there? Okay. So are you there request here? And in this scenario means what is, okay, let's consider in this, the case two is here, like that site is down. Okay, so site can be down because of some reasons. Okay, that could be, might be the device got powered off. Okay, or might be, is there any hardware issue with that? Okay, or might be that interface itself is down. Okay, so there could be the multiple reason for the down. Okay, so right now that is down and the device is not able to reply here. Okay, so what will be there? This site, or this site A, who has sent and a first packet, which is, are you there request here. So it would wait for the how much time? 10 seconds here. The reason, because we have defined a timer here as a 10 seconds. Okay, so this is the minimum timer is 10 second only. So there's a 10 second. After 10 second, it would send one more, which is again, are you there? So again, it would send it, are you there request. This is the one more. This is second. Then it would send third. After again 10 second. This is the fourth, and this is the no fifth here. But there is a no reply. After the 5 tries, it would declare here, yes, now site B is done. Are you getting my point? This is, they have sent it 0 second. This is you can set 1 second at time t0. You can say this is at time t0. That is 1 second here. This is the time 1, which is here 11 second now, because after 10 second, this is time t2, sorry, t2 now. So this is about 21 second. Then it's about 31 second, and this is about 41 second. So overall, okay, if you can say after 50 seconds, okay, it would declare, yes, site B is what? Site B is down here. Clear or not, guys? Okay, so this is the concept here. So now question is the keep alive. Okay, the keep alive messages which we are exchanging here. So what is the time interval into that? That is 10 seconds, where we have decided in the command itself, we have mentioned how many times we can send it. We can send a keep alive, or we can send a keep alive here. The timer is 5, which we cannot change it because this is the default timer. Site B is down now. That's down now. So now we cannot exchange any. The reason the channel is down. So instead of sending 1 TB file, okay, so we just got to know that yes, site B is already down, and we cannot exchange any data. So this concept is TP. So this is the case number 2 is clear or not, guys? So for how long you have to wait? So for how long the site A has to wait to declare site B as a down? It would take 50 seconds. Yes, is this clear?
Yes.
Any doubt, any questions in this? Anyone? So this, because site B is taking a 50 seconds here to declare site B as a down. Okay, so this is a too much time. Well, let's consider. This is once your phase 1 and phase 2 both are up. Okay, this is not relevant to the phases. This is after the when everything has been up and you have exchanged some data earlier, but after that session is idle. So here the site A has to wait for the 50 second. Let's consider, guys, and let's consider I have to ask something to Pawan, for example. And I'm asking, hi Pawan, are you there? I'm asking him, right? He's no reply. Okay. So this is kind of DPD now. So I have to wait for another 10 seconds. Again, I say, hi, Pawan, are you there? Again, I have to wait for 10 seconds. So this is a time taking process. So I do not want to wait for the 10 seconds here. So what I'll do it, I'll just mention here one timer that is known as aggressive timer. That is known as aggressive timer. Aggressive timer means what? Means after first keep alive. Okay, after first message, you can say after first message, if we are not getting any reply from the side B, so then no need to wait for another 10 seconds. Let's consider this is the first, you have sent it at 0 and you are waiting till the 10 seconds. So no need to wait for the 10 seconds if your another site is not replying. So do one thing. This is the 10-second is the timer here, right? Guess what is the timer here in between? What is the time to the difference? 10 seconds. This is again 10 seconds here. We have 10 seconds here. Then we have again 10 seconds here. This is a 10 seconds here. 10 seconds here again. And 10 seconds. So overall, it takes 50 seconds for site A to declare site B as a dead. So we do not have that much time because in after first message itself, they are not their site B is not replying. So I just tried to send these. This question is, can I send these like other remaining 4 messages bit early? Answer is yes. So aggressive timer we have to set, and let's consider I have set it 3 seconds. So what happened? I have sent first message. Message number 1. Message 1 here, there is a no reply. So instead of waiting for the 10 seconds, I'll wait, okay, for the what? Listen, message number 1, it will wait for the first message, it will wait for the 10 seconds. No reply. After that, I'll second message number 2 at 11 seconds because 0 to 10 first over and now 11 seconds. After that, even again, there is a no reply. Then message number 3, I'll send it after 3 seconds, which is 14. Message 4 is 17 and message 5 is again 20. So within 20 seconds, site A would declare that site B is down here. So this 3 second is known as your aggressive timer. Yes, site A is just more aggressive now. Okay, because site A don't want to wait for a long to be declare it as a dead if site B is not like sending the reply. Yes, guys, is this clear? Okay. Anyone, any doubt, any questions here? So now we have to configure all this thing. So guys, first of all, it's just difficult to get these kind of outputs here. Okay, but still you can use the GNS. Okay. Sometime we get the output for the same, sometime not also. So, but I'll just show you how to configure it here. Okay. So just let me start with this. GNS is required for this EVNG, so you cannot expect any kind of output. EVNG, GNS. Now after this, let me start it GNS from outside. So two routers I'm going to be using. Both are fast Ethernet. So let me just, here I'll just mention IP as a 11.1, 11.1.1.1.1. This is again 11.1.1.1.2. Loop back 0, 1.1.1.1. Loop back again here 0, 2.2.2.2. Here I'll mention its configuration. It would be easy for us. It would be faster as well. The host name, site A, interface F0/0, IP address 11.1.1.1.1. Okay. Now this is for site B. This is .2. This is .1. And this is 2.2.2.2. After this, about the VPN here, crypto as a camp policy 10. Then about encryption 3 dash, hashing MD5, group 2, authentication, ratio, exit. Crypto as a camp key, Cisco, address 11.1.1.1.2. Crypto IP set, transform set name is tset ESP 3 dash ESP MD5. Access list 101 permit IP. So about the source is 1.1.1.0 wildcard mask 2.2.0 wildcard mask. Crypto map IMAP 10 IP set as a camp set peer 11.1.1.2 match address 101. Okay, and after that set transform set reset etc. Windows 0. Now mentioned here crypto map name is IMAP. So copy and let me paste it on the site. Nothing all okay? Yes. This would be .1. For another device, it would be 2.2.2.2. Network, this is fine here, 11.1. And this is .1. Copy and paste on site. It's clear. Now first of all, ping with 11.1.1.1.2. reachability is there, it's fine. OIP sec. Packets are getting. So guys, up to here, I hope this is clear. Any doubt, any questions, anyone? I hope all clear, right? Yeah. So now we have to set the timer. So timer, let me just define it here. Crypto, I say camp, keep alive. Question. The number of seconds between the keep alive, the timer, what you want to set it, key after what is the timer here, right? So that is about 10 seconds. The number of seconds, the difference between that. Okay, first message sent like at 10 seconds. After that second is after 10 seconds, then 10 seconds, and then 10 second here. And just mention it on demand. So this is without any aggressive timer we have configured it. But we won't be able to see the captures for these kind of things here. That is not possible. Okay, if you would just want to set it out here again, you can. But captures we cannot see for this. Okay, so you can just try to do this as all about clear crypto session. And after that, if you would try to ping it out here, you can ping, but keep alive messages, we cannot capture it. Okay, so that's not possible. Okay, so what we have to do it right now, instead of doing this, we have to set a now aggressive timer with this. Okay, so what I'll do it, I'll just remove this. And after aggressive timer, we would be able to see the kind of captures into this. Even that is also not sure here. This is I have removed. Now let me define it again here. Crypto as a camp, keep, keep alive 10 seconds, because minimum timer, as you can see, that is a 10 seconds here, maximum 3600 seconds, because that is all about the timer for your maximum timer for the phase 2 here. So I'll just mention the minimum timer. After that, you can see we have a concept about next timer. I have to set it. Let's consider I have set it 3. So what is the meaning of 3? The 3 meanings here, this is the number of seconds between retries if keep alive fails. Number of seconds between retries if keep alive fails. So guys, try to just read this statement and just try to understand what exactly this line is saying. Kindly take your time, 30 seconds, and just try to understand what this line is saying exactly. So this is number of seconds between retries. So this is like if your keep alive fails, okay, you are not getting reply. So what is the next timer here? It will not wait for another 10 seconds or okay. So it will just go with the aggressive timer here, which is about what? Which is about 3 seconds. So minimum timer is 2, maximum is 60, but I have set it here 3, and then as a on demand. On demand, copy this, paste on this here now. And after that, just mention here, clear crypto session. And after that, try to ping it again here. That is fine. We have pinged, everything is fine. So now on the another side, okay, I'll just debug IP packet. I have enabled the packet here. So now I'll wait here for the just 1 minute. Okay, and after 1 minute, I'll again generate the packet. So in that scenario, first it would send what? It would send your one keep alive message like as a are you there DPD. Okay, so that we have to capture on this side. Even with the help of Wireshark, you won't be able to capture those kind of stuff. But still, I'll just enable it. Start the captures. No issue, Santosh. Okay. So we have to wait for at least minimum 1 minute. Okay, we will show crypto. Like we said. This is fine. Years and all this one. You can see. We have to just wait for a 1 minute kind of stuff here. Okay. And after that only they would send the keep live messages. Okay. Just we have to generate the packets and after that only it would send the keep live messages. So about output here even now because on the real devices these kind of outputs possible. Okay. On simulators, even on EVNG, so forget about that. That's not possible. Even you can see here in this output. Right now, our next concept I'll start as a PFS. Next topic is my PFS pseudo function here. So see, in the pseudo function, there will be an output about the pseudo function here or here. There will be one PFS value will be there, but you can see in this output here, we cannot see any pseudo function output here. Even I'll show you on EVNG. That's the reason even I have started EVNG here. Okay. And after this task, I'll take you to for the PFS. Okay, 1.14. Let me start here the devices. Now I'll show you the same with the help of the same command. We would be able to say it on PFS. We can see the PFS output we can see on EVNG, but that's not possible on GNS. Okay, it's the VPN lab here. So basic. I think this is the one of the basic one. Yeah, this is fine. Let me start with this. So I'll be back here now. I think it's more than 1 minute. So now just here from here, I'll generate a message here. I'll just ping now. Ping with 2.2.2.2 at the source of 1.1.1. Able to ping, and I'll just check it out here. Are you there, packet? We have to try to find out here. Are you there, packet is there or not? Integrated fast Ethernet here. Debugging on. Just as I can, I'll just capture it here. Just wait for this 50 to 60 seconds, and again I'll generate the packet. Here also the captures, I don't think so we can see. This is informational messages. This is actually DPD here because that would be exchanged with the help of informational messages. But here exact outputs we cannot see because this is all about encrypted and also this is not possible here. So just wait. And this time I have enabled the debugging for the ISACAMP. So let's just wait for the another 30 to 40 seconds. So guys, have you gone through just basics of MPLS? I hope so you have completed that. Like the difference between MPLS and the basic ISP, right? No. And now let's try to send the packet again here, and this time is about ISACAM. And you can see DPD user. Can you see guys now? DPD user. Okay. And this is DPD user acknowledge. So this is the reply, and this is request for this. Okay. So now you can see here DPD, are you there? This is what? Request. And DPD, are you there? This is acknowledgement. So this is source IP from 11.1. So this, it has come from 11.1. Okay. And this is about from 11.2. Okay. This is sending. This is sending, right? And this is, are you there? It's all about received process. Clear? Only H is used, we can see. No, we cannot see that also. Well, that is not the data one. That is ISACAM. This is not IPsec packet. This is ISACAM. Okay, so that's the reason I have enabled it for ISACAM, not IPsec. That is into IPsec. Okay, so this is, are you there? This packet. Okay, and this is, are you there? Acknowledgement, which is sending it. This is packet received from 11.1, destination port this, source port this, okay, as a notify, as a informational messages. So this is as a informational messages here, but exactly that is DPDU. So again, if you would try to ping here, okay, so that would be again happen here. Same. So guys, is this clear? What exactly DPD and how you can just verify it? This is the way to verify. Okay. This is not possible on EVNG, only on GNS3. Only Santo. Okay. So now show crypto IPsec SA. So now guys, is there anything you can see related to PFS here? Is there any related to PFS output here? There's a no PFS keyword here. Okay. So what is PFS? Because PFS practical not possible on GNS. For that, you have to get into the EVNG. So guys, I hope DPT is clear to everyone.
Yes, sir.
Right? So for that, you have to use GNS. Okay. So now I'll close this. I'll stop it. Even this is not needed. So let me just close this. Next concept we have PFS, pseudo function. Not very important. Yeah, from interview, it's very important. PFS. Okay. In case if you're applying for the checkpoint or for the barcode and all, okay. So PFS is just very important there. Now, guys, in this batch, how many of you are freshers? Like recent pass out or 1, 2, 3 years back? Like who is 20 onwards? Is there anyone? Pawan is there. Benita is there. Sushil, okay. Guys, make a group. Okay, fine. Make a group and now make a group here. Like earlier, I'm not sure you just heard about one group. There was a group of Deep Raj, and then one is Pankaj, one is Neetu, and one is Vijay. Okay, 5, 6 guys. They were very good actually, and they just made a group here. Okay, so I'll just suggest you make a group and just try to prepare yourself for the interviews. Okay, so that group was very good actually. They were regular in the physical classes and in online classes as well. Okay, so try to make a group and just try to prepare for interview and start preparing for it. Benita, I think you met that Neetu and all, right?
Yes, sir.
Yeah, so she got selected, I think. I hope you know, right? In
No,
checkpoint.
sir, I haven't met her after classes. I have
Okay.
to call and ask her.
Yeah. So it's okay. You can just guys just try to take some inputs from them, Benita, like as you are in touch with the Neetu and all. So because after 1 month, 2 months, they won't reply. So right now they just recently joined. So recently, so they can just reply. Okay. And so just try to be in touch with those guys. Even they have already shared the list of the questions what the like interviewer has asked in the checkpoint. So that is very easy. So if you're very good in TCP, VPN, and basics of ASA, so I think so you are ready for the checkpoint interviews at least. Okay. The checkpoint is one of the product-based company and just start appearing for the interviews. But before checkpoint, just try to clear your mock interviews. Try to appear 2, 3, 4 times for the mock interviews. Because I think after Diwali, there will be so many openings in the checkpoints. Okay, because they have just given us a high hint. You just prepare at least 150 students after Diwali. So there would be huge demand from the checkpoints. Okay, because they are expanding their infrastructures right now. So there would be huge demand. Okay, so just be ready for that. And VPN is very important for them. Okay, especially IPsec handshake and this DPD and this PFS and NAT-T, SSL handshake. Okay, so these are the very important things. So now let's talk about PFS. What is the meaning of PFS? So guys, let's try to recall your ISAC and IPsec here. So in IPsec, we have discussed, we have phase 1, then we have a phase 2. We have phase 1, and then we have a phase 2 here. So in a phase 2, so this is all about my quick mode here. This is all about my, this is not quick, sorry. This is the main mode. And this is all about quick mode. So in main mode, okay, in main mode, guys, how many message exchange we have? 6 messages, right? And second, we have how many messages here? 3 messages here. So in the 6th message, in the first message here, it's all about Haggle. Second is again Haggle here. Both are Haggle. Third and fourth is all about Diffie-Hellman. Okay, and then 5th and 6th is all about your authentication. So this is all about Haggle here. And this is all about Diffie-Hellman. And this is about authentication. Okay, so what is the Diffie-Hellman? Diffie-Hellman help us to what? To exchange. They have exchanged what? This is the keying material, right? They have exchanged the keys, and this is the keying material which is common on both the sides. So first of all, authentication. In authentication, that encrypt, these are the encrypted packets, guys. Am I right? These are the what? These are the encrypted messages. So encrypted messages. So these encrypted messages, these are the earlier before this, all the messages are in the plain text, but this is about into the encrypted one. And now my phase 1 is over. But in phase 2, then again we are exchanging what? The ESP protocol we are using. Let's consider ESP or AH, and ESP we are going to be used. Let's consider here in Haggle I have defined the encryption with dash and hashing with MD5. But here I can define in ESP. For encryption, I'm going to be use ES, and for hashing, I'm going to be use SHA. So guys, this is possible or not? Yes, can kindly acknowledge. Is this possible? Right? We can define a different encryption and hashing algorithm in phase 2 in ESP. Am I right? Guys.
Yes, sir.
Right? Only one reply. What about other students?
Yes.
I hope you remember, right? All this.
Yes, sir.
Yes, yes.
But now just tell me one thing here. See, when we are exchanging the data here, this is the data which is going to be encrypted and hashed, which we are going to be encrypted and hashed, which keys we are going to be use it now. From where we are going to be use the keys? For here, we need keys. So from where we are going to be use it these keys, guys? In phase 2. From where we are going to be use the keys here? Because for encryption and hashing, we need a keys, right? Without keys, we cannot do that, right? That is the raw material. So from where we will get these keys, guys? Anyone, any reply here? Yes, Benita, you tell me.
So through Diffie-Hellman key exchange, we have already exchanged the keys, right, sir?
Exactly. So which we have already exchanged, these are the keys that are going to be used, which we have already exchanged. Guys, what happened to other guys? Like, this is just easy question. What happened, Pawan and Santosh? No reply for the same. Okay, because we have already exchanged the keys where we have exchanged the keys in the phase 1. So that same concept, the same we are going to be use it over here, right? The same concept we are using it here. Okay. So my question is, let's consider this is my phase 1. My phase 1. In the phase 1, we have the keying material. And this is the same keying material I'm going to be using to phase 2. Okay, because phase 1 keying material we are going to use in phase 2. Phase 1 keying material and we are going to be using to what? Phase 2 here. So that is okay. We know that phase 1 is also secure, but I'm saying at a worst case. The worst case, let's consider there's a one worst case here. In that worst case, what is there? Phase 1 of IPsec, the phase 1, only phase 1 of IPsec got hacked. Okay, so it means now that hacker has the access of your team. Yes, guys. Am I right or not? Yes, guys. Am I right or not? I'm waiting for your reply. Is this clear or not? Somehow, because if we have some advanced security concepts, so they have also advanced tools and advanced concepts they're using to hack the networks and the thing, right? So this is we have. So right now, so now hacker has access of your keying material, okay, which is in phase 1 here. Okay, so now easily, okay, the hackers, okay, can decrypt your actual data which we are exchanging in phase 2. But keys are same, right? That is the combination because only there's a, let's consider there's a 3 algorithms or devices are supporting AES, dash and 3 dash. Okay, and SHA and MD5. So that combination is fine. That hackers can get to know, okay, they would get it with the help of permutation and computation. Okay, so they would get to know, okay, which one, which algorithms you are using, because algorithm everyone is knows, right? Is even in the during IPsec concert, we have discussed the same thing. Everyone knows about dash and 3 dash and AES, right? But what is the important here? Algorithm is not an important concept because everyone is knows about that. The important thing is keying material. The key is important. Okay, because when the algorithms would perform encryption or decryption, so then they need like keys there, and that keys is important here. So that's the reason we have a Diffie-Hellman which help us to exchange the keying material or a key between both two sites, okay, securely over the internet. So, but right now what happened? Ki this hackers, they're also very smart, and somehow they managed with your phase one. So they hacked your phase one and they have the keying material. So it means now your phase two is also on the stake. So for the more security, what we can do it here, for the further more security, if you want to add some advanced security here in the context of this concept here. So just in phase two, in phase two, in phase two again, okay, exchange that we have. Okay, means generate different keying material for phase two. Okay, do not use phase one. Is this clear? What I'm trying to explain here, what I'm trying to explain, is this clear?
Yes, sir.
Question is how? Answer is with keys. Okay, but if you would try to capture the packet, that's not possible. Capturing the packet is not possible here. Okay, we can just see the only just one basic output here, that okay. So capture is not possible. For that capturing, you need the license-based Wireshark. And right now we do not have any license-based Wireshark. Okay, so now I'll show you here. And for this output, this is again here, I'm going to use 11.1, 11.2. This is a fresh router. Fresh router here. Here I'll mention 11.1.1.1 IP. Go back here. Just 20. This is into this, and this side is again. So we have already all the commands. So instead of these are the interfaces. Here, replace with this is 0/0. Other things are fine. This is also 0/0. So this is site A. This is site B now. This is site B here. And now after that, this is fine. And now this is G again. Copy for site A. And this is copy for site B now. as a campus zone. Okay. Let me enable the captures in between both the sides. Try to ping from here, just between both the devices first, 11.1.1.2. It's fine. And now ping with the loop backs. All good. Okay. We have exchanged it successfully. So crypto IPsec asset. So guys, in this output, can you see here? Guys, remember in GNS3 also we tried, but we never seen this kind of output there, right? We tried there, but this like output was not there. But in DeFi, in EVNG, you can see we have PFS now. Is this clear? So it means PFS practically, if you want to do it, you have to do it only on your EVNG. On GNS, that's not possible. Guys, is this clear? Any doubt here? Any questions? Anyone? All clear? Okay. So now, for this, now this is right now PFS as we can see N. What is the meaning of N? I mean, this is a disable. So we have to now make it enable here. Okay. So now, what is the command? Command is get into the crypto map here. IP map 10 IPsec as a camp here and set PFS question mark which Diffie-Hellman group, because PFS I'm going to be used here for the Diffie-Hellman exchange. So they're asking which Diffie-Hellman group. Let's consider group 2. I'll use it here. Copy. This is on site A and now on site B again here. Crypto map, I map here 10 IPsec as a camp set PFS group 2 here. The group must be same on both the sides. Site A, clear crypto session. And now if you would try to ping it again here. So crypto IPsec. So now you can see that we have been yes. And which group? Group number 2. Okay. But if you would try to capture the packets here, and if you are thinking there would be 2 more packets will be there. So no, that won't be there. Just only you can see this as okay. So I have exchanged. This is clear. So there is no extra messages, okay, in between that. Clear. So that captures is not possible. So just only this is the only output which we can see here. That's it. So it means right now there is a different, okay, PFS we have like different keying material for the phase 2. So we are not going to be use phase 1 keying material here. So we are just using phase separate keying material in phase 1 and separate keying material in phase 2. That's it. So guys, is this clear? What is PFS and why we need PFS? So PFS we need to just again to exchange the or to just keep the separate keying material for the phase 1. That's it. All clear? Okay. So I'll just close it now. So now let's move to the get VPN theory. So half of the theory, at least some of the part I'll finish it today, and tomorrow we'll finish the remaining half of the theory, and then it's practical. Okay, because within one class it's not possible, so half of the day we'll use it today. So now, get VPN. Okay, so get VPN is kind of one VPN over the private network. Okay, so get VPN we cannot use over the public IP. Okay, that there is one reason for public, not public IP, public network. Okay, so there is a reason for that. That once I'll explain it, so you would get to know. So these are the first 2 points. The get VPN, this is we use where we use over the private network here. So the get VPN over the private network, or this is not a VPN over the private network. That is okay. So guys, these are the 2 statements here. So right now, what does it mean? What is the meaning of private network here? So private network, if I'll talk about, so when you would try to search it out on internet, or if you would try to refer any book, so there would be in some books there would be first one type of explanation, and in another book might be there would be the different type of explanation here. That definition and explanation depends on your private network. Okay, what is the definition for you about the private network? Might be, let's consider if you are not aware about let's consider if you are not aware about private network, about MPLS, so might be you would use LAN there. So this is about what? This is the LAN, but if you are aware about MPLS, so might be you would use the statement as a MPLS here. Okay, so but we can use the get VPN in both the scenarios. Okay, so let's consider this is because get VPN is also known as one centralized concept here. This is also known as one centralized management here. Okay, I'll explain about the centralized management and all. Okay, so this is about LAN and this is about the MPLS. So we are going to be using the term of the MPLS here over the public, over the private network. And who's the MPLS provider? MPLS is kind of your private transport. What is that? That is a private transport here, which is expensive than public transport. Public transport means I'm talking about the ISP here. Okay, and private transport means I'm talking about here SP. This is known as SP, service provider. So all the vendors who's providing ISP services, they also do provide the services for SP, like which is service provider. But there is a one company I hope everyone knows about Orange. So Orange also is one of the service provider. So they just do provide only MPLS services to the companies. Okay, they are not just providing any regular internet to the customers there. Okay, like Jio and Airtel and BSNL does. Okay, because MPLS services are very expensive. Because MPLS is what? MPLS is your, because what is MPLS? MPLS is kind of label switching. Which concept we have? Label switching, which works as a 2.5 layer. Okay, and what is the MPLS header? MPLS header size is 20 bytes. Even if I talk about IP addresses, that is about 32 byte here. So this is about what? This is 20 byte, 32 bits actually, that is. Okay, so this is again 20 bits concept. Okay, so these are some concepts we have about MPLS. So I'll not explain here MPLS overall. So what overall just I'll give you, but I'll not explain in depth. So let's consider this is site A, this is site B. Okay, this is site C, this is site D here. So they have internet. This is the normal ISP. So normal ISP they have, this is connected with this is connected with this is connected with this, and this is connected with this. So this is all about public IP 11.1. This is about 15.1. This is about 20.1 here, and this is about 30.1 here. So they are just using ISP here. So on top of that, we have discussed we can use IPsec, we can use here GRE. In the GRE, we have discussed about FGRE, which is the static concept. Then we have discussed about DM, VPN also, which is all about dynamic concept. Clear, guys? So these kind of VPNs, we can use it. I can use here. Then we can use certificate authority based as well, CA as well. We can use here SSL also. So these kind of stuff we have discussed, which is over the public network, because ISP is one of your public network here. This is what? Public network. But right now I'm talking about the private network here. But private network doesn't mean that we are using the private IPs over there. Okay, because again, the private network means I'm talking about here. My private network means I'm talking about here MPLS. Okay, so MPLS is faster than your ISP. Okay, and this is secure than your ISP because this is kind of special services here. Okay, so let's consider here we are using 18.1. This is we are talking about 20.1. For example, here it's using 30.1, and this is we are using here again 40.1 here. So this is MPLS. This is kind of what? Private network here, which is faster than ISP. Okay, so this is more secure. We also call it as a 2.5 layer VPN. It works on level switching of 20 bits. Okay, so this is the concept we have. So MPLS is what? This is kind of private network. So this is, you can say in short, if you talk about, this is a just normal flight. This is a normal flight which you are using. This is, you are traveling via Air India. Let's consider this is about Air India flight. Okay, this is the one option you have. Okay, and after that, this is your private jet you have. Very expensive, faster, but overall we cannot be sure here ki when you are flying, okay, in your private jet, so there is no possibility of crash in the air, right? That possibility is there. Okay, so but yes, in case let's consider this is a COVID time and you do not want to travel with other passengers and in the public transport here, so in that scenario, this is, yes, this is your more secure. It could be faster. Okay, obviously it could be faster here. Okay, you don't have to wait for the other people to check in. If you are ready, you can just get into that and we can fly there. So this is the faster, expensive. Okay, this is the difference, overall difference between MPLS and ISP. Guys, is this clear? What is the difference between both? So who are the vendor for this? Jio is one of the vendor. Orange is one of the vendor. Airtel is again one of the vendor for this. Okay, so that's the reason in the service providers, if there is any requirement in service providers, and also most of the time you have to prepare yourself with the BGP and MPLS. Most of the enterprise network students, okay, who CSAT certified and all the guys, okay, so they always love to work in MPLS and you can see the BGP, and that is their backbone. For security, like our VPN is our backbone. Okay, so it's like that, BGP and MPLS is kind of the backbone for them. Okay, guys. So before starting the get VPN, I just want to ask you, is this clear? Any doubt, any questions here? What are the difference between ISP and the MPLS here? I hope this is more clear now. Okay, it's clear. So let's consider now, this is the Cisco's network. Okay, and they're just using like this. Okay, this is Cisco's Bangalore. This is Cisco US. This is about Cisco Dubai. And let's consider this is Cisco Delhi here. So what they have decided instead of using like internet, the public ISP, okay, we would use what? We would prefer the private one here. The private network, or you can say this is kind of your now private ISP. So that is known as service provider. So let's consider they're just using the service of Orange. Okay, because yeah, Orange is one of the corporate, one of the big giant actually, who has a full network all over the world. So what they have decided, ki, okay, we will take the service of the Orange here as a MPLS. And now this is your private network only. Okay, so in this network, only Cisco's data can be exchanged. That's not possible ki other companies are also can connect with the same private network. No. So this is just a private network. Till now, what private network we have learned? Till now, if I'll talk about till now, what private network we have discussed? Okay, private network we have discussed about the LAN. Okay, LAN and WAN here. So this is again same LAN or kind of LAN, not exactly LAN, but yes, you can relate it with the LAN because this is your private network here. So in case if this is your company and this is considered this is your corporate and this is one of ASA you're using and connected with internet. So then this is your edge device connected with internet here. And in some books, this kind of definition also will be there. So this is one of the switch. And this is connected here. And inside that you have multiple routers. Let's consider router 1, router 2, router. Let's consider this is one of the college infrastructure. So this is the block A. This is the block B. This is the block C. And this is the block D here. So where they're using a routers into this like that. Okay. And all the routers are connected with this. Okay. So in this scenario, if you want to use IPsec, so IPsec is not needed because IPsec is again in the context of the headers and all that will take more time. Okay. But in this concept here, I can use a get VPN. So in the some scenarios, this is again my private network only. This is my private network. Okay. And here also we can use get VPN. But most of time, get VPN we use in most of the books. This is the better deployment of your get VPN. So question is, Amit, why get VPN? Because this is secure. Even you have mentioned here, this is secure. But this secure I have mentioned in the context of the ISP. This is a more secure than ISP, but I'm not sure if this is 100% secure. Okay. So now I'll take you to the one of the document and this is, we would read it. Okay. So get VPN. Get VPN is going to be used one protocol that is known as GDWI. I'll explain, we will talk about that. Okay. So what exactly this is? So now you can see, just try to go through this one. However, get VPN is now commonly used for encrypting any type of traffic over any private network. Guys, this is clear? The first statement. Waiting for the acknowledgement. Is this clear?
Yes.
Yes, sir.
Okay. So, however, get VPN is now commonly used for encrypting any type of traffic over any private network here. The private network they have mentioned. Private network can be LAN and it can be MPLS. So most commonly it is used for the encryption over MPLS VPN because MPLS is also, we call it as a 2.5 VPN here. So that is also kind of VPN as per enterprise, but exactly not a VPN. So this is like encryption over the MPLS VPN because, okay, because as a MPLS VPNs are not truly secure because this is, they have considered MPLS as a VPN, but as they have mentioned along with this, key MPLS VPNs are not truly secure. Because see, now let's consider Cisco is one of the bigger giant and they want to exchange some very important files with each other with like bank from the US, which is the headquarter. From here, they want to share some very important file with the other branches here, which is in Bangalore, Delhi, and Dubai. So over the ISP, first of all, they cannot trust them because that is not secure. So that's the reason they have taken which one? MPLS from the Orange. But on top of that also, the question is, Amit, can we exchange the data in clear text over why you because MPLS is private network. So can we exchange it? Okay. Answer is definitely no. Because blindly I cannot trust the orange organization. Are you getting my point, guys? Okay. The reason is, see, I am saying ki no. You can see, we can understand MPLS is your private network, which is faster, providing you better security than your ISP and all. But still, blindly, I'm not going to be trust. Okay, Orange or the Airtel here. Okay, might be I'm exchanging my data in the clear text here. Okay, so what would happen? They would be able to see my data, and that I do not want it here. So I just want same again kind of encryption and hashing and kind of authentication. Okay, over the MPLS also. So means again I have to use the VPN here. So question is, okay, then do one thing, use IPsec. I'm saying no, because there is a one IP preservation is not there. Okay. The question is, can we use IPsec over MPLS? Okay, you can. I'm not saying you cannot. You can, but not recommended. Okay, the reason because IPsec does not support IP preservation. So what is IP preservation? That we will talk about. But MPLS does support your IP preservation. So for IP address preservation, I'll explain it tomorrow. Okay. So, but before this, you can see here, most commonly it is used for encryption over MPLS VPN. MPLS VPN are not truly secure because still this is the third party one. It's a third party. And without encryption, you are putting a lot of faith that your service provider won't sniff your data. So this is again the same statement. Okay, if you are not exchanging data in the encrypted format over the MPLS here, okay, by using some algorithms, if you're sending in the clear text, so it means you are putting a lot of faith that your service provider won't sniff your data. So that is not a good concept. Okay, so that is not recommended. So however, Get VPN is a L2 to L3 agnostics, and it could be used for any application where NAT is not in. Okay, the question is, Amit, NAT is obviously NAT will be not involved into private network, or is there any possibility, guys? Obviously, NAT is not involved. Okay, so here again over the MPLS, first of all, on MPLS we don't use NAT here. That is the one concept. Okay, and second concept is, guys, if you are using here private network, so this is, so do you think, guys, we need a NAT into my private network here? Okay, I can understand you don't, you are not aware about MPLS, okay, that much, but at least LAN network, so you know, right? So do we need any NATing concept inside the LAN network, guys? Kindly answer for
No,
this.
sir.
No, right? Because that is the private network. We are not connecting here with the public. And when we need a NAT, we need a NAT when your traffic is like going from the private to the public. So in that scenario, that is needed here. But MPLS is again kind of your private network only. So there NAT is not involved. So Get VPN does not replace DM VPN. So don't think it's going to be replace the DM VPN, because here when we'll start digging the Get VPN, that you would at some point you would feel that this is kind of similar to the DM VPN, but no, that is not exactly the DM VPN, and that is not going to be replace the DM VPN because of just one statement, which is known as IP address preservation, which we'll discuss tomorrow, not today. Okay, so now if you would go down here, Get VPN is meant for the private network like MPLS VPN, where you have full reachability between all the sites. Okay, so here, like MPLS would provide all the reachability between all the sites here. So before starting the configuration of the Get VPN, you have to make sure that there should be proper reachability between them. Okay, and who would provide the reachability? MPLS. But yes, that would be faster. That is a different thing. Okay, so this is about node now. This is related to the IP. Okay, so in get VPN, now we have, if you would talk about in get VPN, so we have some important terms here. So one is GM. This is known as group membership. Then we have KS, which is known as key server. Okay. After that, we have GDI. This is one of the protocol. GDI is one of the protocol, guys. Okay. GDI full form, I'll tell you, that is something. I don't think so. Is there any full form here of GDI? Yeah, group encrypted transport VPN. This is, and guys, very important thing, this is Cisco proprietary. Cisco proprietary means this is only Cisco's VPN here. Okay, so this is not any open standard, so only Cisco's use this concept here. So just this is just a Cisco proprietary concept. Okay, so Cisco's group encrypted transport VPN. Clear? So we have three important terms here. So which is group member, key server, and GDI. So who would be key server? My headquarter or any one device would be my key server. Okay, you can see overall there would be one key server and remaining n minus one devices would be act as a group member here. Okay, so like see, you remember in DM VPN we have used headquarter and spoke, hub and spoke concept. It was a hub that time. It was a hub, and this is the concept about spoke. So this is kind of similar stuff. We would use it, but we would use centralized key management here. Okay. So further, okay. So GetVPN introduced the concept of trusted group to eliminate point-to-point tunnel. So we do not have any kind of point-to-point tunnel into this. Like earlier, we have seen point-to-point tunnel. Even in DM VPN also, we have seen point-to-point tunnel between spoke to spoke, spoke 1 to spoke 2, spoke 1 to spoke 3, that kind of. But here, we do not have that concept here. So it's now eliminate what? Point-to-point tunnel and their associated overlay routing. So we do not have concept about overlay routing as well here. Underlay overlay we have seen, so but we do not have that concept here. So we have a group member which shared a common essays. Okay, so this is, guys, technically we will talk about tomorrow only, not today, because now I have to get into that. So these are the some technology: GDI, key server, group member. Okay. So I think it will take 2 days because we have COOPS option as well. So I think tomorrow we'll start with this. So another 2 days we have to spend with the get VPN only. So tomorrow, because along with that, I have shown you practical also. So along with this, we will do it at the same time. Okay. So this is overall difference between ISP and MPLS here. So get VPN is kind of one VPN which we have to use it over the private network. So get VPN we have to use over the private network. Okay, so here we have centralized key distribution. Okay, we use same keys on all the group members. Okay, for encryption and decryption, and for the encryption and decryption, the same keys. Okay, same key. Okay, so we don't have to use the separate keys here. So we have to always use what? Same keys for the same. Okay, so what is the meaning of this statement? Just one minute here. So let's consider this is the hub. This is POC 1, this is POC 2, this is POC 3. Okay, connected here. So with the help of DM VPN, okay, we have configured the same with the help of the same tunnels concept we were using it, right? Tunnel concept was a okay that we were using the same. Means here if I'm using 192.168.1.1, so here I'm using 1.2. Here it was concept about 1.3. Here the concept about 1.4 here. So we have MPLS helped us to solve this problem. Instead of using multiple tunnels there, we are just using the single tunnel. But whenever these spokes to spokes communication was happening, they were using different keys here for the encryption and different keys for the encryption decryption. Guys, do you remember this concept? Right? Okay. So as a like this site, if this site has a 3 tunnels with the same interface, but overall this site has to manage 3 keys. A key is for site 1.2, keys B, which is 1.3, C is for 1.4. So over the public network, this is a good solution which would help us. But between the private network, I do not want a separate keys here. What I want, let's consider if I'm using a get VPN. So this would be my key server. This would be my group member 1, group member 2, group member 3. And I'm going to be use only one key, which is A. So where all the devices, all the group members would use key A for encryption and decryption. This is also key A. This is also key A. So we do not have separate keys concept because I'm not using ISP. Okay, I'm using here what? I'm using MPLS, which is my private network. So having a separate keys over the public IP is recommended, but having a separate keys, okay, over the private network is not recommended here. So for that scenario, we need a centralized system, and that's the reason we have get VPN concept. Okay, so this is the brief idea I have given. Tomorrow we will start with this, and tomorrow's lecture would be a bit long. That would be might be for like that can cross up to 2 hours also. Okay, because I have to finish theory and practical at the same time. Okay. So just kindly try to go through the today's videos. Okay, it would be better, and you would get the more like confident tomorrow about it. No, that we don't have. PFS is not there in Get VPN. Okay. So guys, I'm done for this. So any doubt, any questions, if you have, so you can ask me, or then else see you tomorrow. Any doubt, any questions? All clear? So shall I close the meeting? Okay. So guys, see you tomorrow, and don't miss your next 2 sessions, which is going to be very, very important here. Okay. So do not miss your Get VPN. Okay, guys. So then see you tomorrow. Bye-bye. Take care. Have a nice day. Thank you.